So guys, thank you very much for attending this presentation. Thank you very much for being here. I know it's the last presentation of the day, so we also have a keynote after, but you are most likely already tired, and you've learned so many things already from the previous speakers. Excellent presentations, by the way, so I pretty much enjoyed each and every minute of this conference, of this couple of days conference by now. So it's always I'm always glad to be here at Vox Days and discuss with you. Don't wait up to the end of the presentation. Just throw your questions in the chat. I have an eye on Rocket here, and I will try answering your questions on the fly. Just let me know when you have questions. And stay with me, because first of all, today we discuss a subject that you will find pretty much relevant for practical use. If you want to know some tips and tricks about how to deliver less problems in production, then this is a presentation for you. And I'm pretty sure that all of you want to learn how to deploy less problems to their users. And of course, at the very end of the presentation, I will share in chat with you two codes for the lucky ones who will be able to take for free the last book I'm writing. So 5 most useful profiling techniques to use with modern Java apps. And I'm pretty much sure that a lot of you wonder what has this to do with practical Java, because somehow people tend to believe that profiling is something that you don't use on a daily basis. And today I'm going to prove you wrong. I'm going to prove you that there are things that you should use on a daily basis in terms of profiling your applications. And I'm going to show you how these techniques will help you improve the quality of your deliveries. Of course, before going deeper into the subject, for those of you who don't know me, I'm Laurentiu. I wrote a couple of books. I'm writing the third one now. And I'm also online almost everywhere. Join me on my YouTube channel, Twitter, LinkedIn, and of course, I also have a blog. And I'm writing now the third book, which is on basically investigation techniques, including debugging and profiling. I want to tell you that I only have a little bit more than a half an hour today to discuss with you a lot of cool stuff. But of course, half of an hour is not enough to discuss about all the relevant things that will make you more efficient in writing your applications. So this book extensively describes further most of the things that I'm going to tell you today, and a lot more. So give it a chance. Now, profiling again. When you think about profiling today, the popular opinion today is that profiling is for maybe investigative thread-related issues, multi-thread architectures. What should I do with profiling today? Because, well, I have some Spring applications, I use frameworks, I do use whatever, Hibernate to connect to my database. Maybe I'm writing a reactive application, so I'm using behind the scenes reactive core. But when would I actually need profiling? Where profiling, contrary to the popular opinion, is not about investigating, and not only about investigating thread-related issues. So you can basically imagine profiling as an X-ray of your application execution. And when I say an X-ray, it means that you basically see through the execution of your application, and you can see a lot of things, including which are the HTTP calls your app gets and which are the HTTP calls your app receives. Are you writing web applications with, say, Spring MVC behind the scenes in a Spring Boot application? Well, in that case, you will make you would make good use of profiling techniques to find out if, for example, some client sends too many requests, which overflows your application, or maybe the other way around. Your application sends too many requests to a different service, which might overflow that one. Is your application sending queries to a database, whether they are to a relational database, or maybe you use a NoSQL technology such as Mongo, Cassandra, Redis, and so on? Well, you can use profiling to understand how is your app communicating to the persistence layer, and to find out if you have issues on that side. So see where I'm going, you will have you will find good usage of profiling techniques with modern applications, whether they are applications implemented with Spring or Quarkus, whether they are applications that use Hibernate, Spring Data, JDBC, or maybe connect directly via JDBC, via the JDBC APIs provided by the JDK. So whichever your choice is in your application, you can use this X-ray of profiling to see through the execution. So you can see what code executes, you can see how your app collaborates with your database, and I will prove you how useful is this with a JPA implementation such as Hibernate. You can see how your application consumes different resources, especially in terms of CPU and memory. So let's start with my favorite, which is investigating SQL queries. Maybe you're gonna ask, why is this my favorite? Because I'm using, at the moment, I'm basically writing applications that behind the scenes use Hibernate, and the past couple of years, most of them used Spring Data JPA, which with the convention configured by Spring Boot behind the scenes is Hibernate, which, as you know, is a JPA implementation. And well, the problem is that whenever you use Hibernate, and even more when you use Spring Data JPA, which has Hibernate behind the scenes, you don't necessarily, first of all, write the queries directly. That's even not a good practice. You don't write native queries often. You write JPQL queries. And of course, you might say, yeah, what can be wrong with that? Well, first of all, when you have a JPQL query, you can't easily just copy paste it into a SQL client, for example, to get an explain plan and investigate that query. Sometimes it's difficult to see what happens behind the scenes, because you might write a query, but you might introduce a very small mistake in a join or a fetching you're writing, and then you introduce an n+1 problem. And I know n+1 problem is theoretically a simple one that you might think that you should see from the beginning, from the development timing. But well, at least for me, well, it happens that, well, I'm taking out my ID, I'm reading it, I'm not Vlad Mihalcha, so I need some more different ways to make sure that I'm doing the right thing here. So it might happen, it happened to me that I introduced problems and I had to verify my execution to make sure that it works properly. I found out that it doesn't, and then I corrected the problem, but I corrected it before delivering it to production. And in some cases, you might not even see a query, because if you are writing criteria query, for example, you won't see the queries at all. So I know you can enable the logging, of course, but have you ever enabled the log with an n+1 problem on a query that retrieves about 1,000 records to see how it looks like? A little bit difficult. For those of you who did that, you might have find it difficult to understand what happens and which are the exact queries and how are they linked together. But with a profiling tool, it's much easier to see that. So in a profiling tool, even in the simplest and cheapest profiling tool, which is Visual VM, which is my favorite, by the way, you can see queries which are generated by your application. This is a nice example here, and I'm gonna show you how this looks like in an example. I'm gonna pop up some IntelliJ window in my Visual VM, and I'm gonna show you how you see these queries very easily without even needing to introduce any logging for this. How it happens behind the scenes, well, it's pretty easy. You and all of us know that when you have a query sent by your application, whether it's sent through an ORM framework or you send it directly through a JDBC, well, the JDBC driver is basically the one that comes with the implementations specific to your DBMS technology, which means that profiling tools such as Visual VM, for example, can easily intercept the JDBC driver calls and extract from there all the data, including the SQL queries that are sent and the parameters. So you can basically see the JDBC driver as a proxy, and being that this is the gateway, let's call it the gateway to the DBMS, then the profiling tool can very easily consume the data from there and display it for you and make statistics over it. So let's try it. Why not? So that's the whole idea. I will quickly just take out my IntelliJ window here, and this is a very simple application. I promise you, it's using Spring Data JPA behind the scenes. It's even implemented. I think this example is even the one implemented with using criteria query. I will show you one of the repositories, so you can see the implementation here. It's a very simple implementation using a few lines of code of criteria query to prove you don't see any kind of SQL here. I will basically start this application, and I would like to find out if there is any possibility to understand which are the queries sent behind the scenes by my application without even having to analyze this code. And I'm going to do that only using my profiler. And that's pretty simple. I should see now the process in my visual VM. So I have a visual VM, latest version installed here, free. Just take it from just take it to your computer. I have to basically restart it, I think, because I see that the process doesn't appear here, and sometimes it happens to me that the profiler doesn't link correctly. I'm going to start it again. And now I see it here. Perfect. So this is my process. I easily identify it through the name of the main class, the fully qualified name. And you have this directly the JDBC button that starts a profiler on the JDBC queries. So I simply implemented an endpoint, and when I'm going to call this endpoint that I can show you in the application just to make sure that you trust me, I'm doing the right thing here. So products is the endpoint, and I'm using a postman to call this products endpoint that will theoretically retrieve some data from my database. So here it is. It's now going to retrieve the data. In my postman, you don't necessarily have to see, but the endpoint responded with 200 OK. But what you see here is that that the visual VM basically intercepted both queries. There are two queries executing. One of them is taking some kind of record from one of the tables, and then the other one iterates 10 times, creating 10 invocations. This is basically a poor design, implemented, of course, in this example on purpose, so that you can see how easily you can spot poor designs like this one. For example, when you get something like your app retrieves a query, and then you see 10 times the same query being executed, you might want to figure out if that is really what you want to happen, because in some cases this pattern, when you see this pattern, it can be basically a bad n+1 kind of problem, which is in my case, but in this example implemented, of course, on purpose. One other thing that you can see here is that in the profiler itself, you can see this is the exact native query, the way it has been built by Hibernate. So it looks strange. The reason it has these strange names here, like product 0, so this alias is here and so on. This is because this is not written by a human hand in the application. This is what has been behind the scenes dynamically generated by the Hibernate. And my visual VM was able to intercept the queries. I can now copy them instantaneous. If I want to copy them, I just copy it from here. I can run it in case I want to, for example, investigate the explain plan. I can see how long it took. I can see the number of invocations, and I can even see, if I want to go deeper, from what part of the application actually generated this. So I can go on the stack, on the execution stack, and identify exactly the method, services, controllers, repositories that generated the execution of this query. So I immediately identify where in my application this query has been generated, which saves me a lot of investigation time, because how much did it take me to do that? A couple of minutes at most. I get all this information, and then I have everything I need to see if it is a problem or not. And this is something that I use almost on a daily basis. So when I say on a daily basis, I'm actually pretty much serious. It's part of the definition of done of any increment we are creating in an application I'm working for, in a team I'm working for. And the reason is, if you implement something and you take those 5 minutes maximum to run the profiling on JDBC queries, especially if you are using especially if you are using an ORM framework or something that is more difficult to understand behind the scenes what happens, and you are not sure if you wrote the code correctly and the queries that you wrote are the ones that you expected to go, then this is something you really need to do for each and every capability you implement. That way you make sure you don't introduce performance problems or even completely bugs in your application, because I will not spend a lot of time anymore to show you that, but in my application here, for example, I actually introduced a bug on purpose. If you do something like this, so if you call the from method 2 times in a row instead, what will happen is that it will create a cross product, and this is actually not only creating a performance problem, but it creates also it potentially creates also a bug, an output bug in your application. And a question from the audience: so is it possible to use profiling for intercepting queries which are sent through a reactive application, R2DBC for instance? Well, thank you very much for the question. Actually, the answer is, from what I know at the moment, I tried myself to use both the JProfiler and the Visual VM to intercept the queries as they are sent by an R2DBC implementation, and I wasn't successful. So I would tend to answer that the answer is no, and that wasn't long ago. So most likely for reactive applications, we will still have to wait a bit for the profiling tools to adapt that as well. So thank you very much for the question. Going back to my presentation now, so I'd like to go back to my presentation and go to the second, finding hotspots. So what are hotspots? There are places in your execution that are potentially intensive for CPU or memory usage. You get this kind of a hotspot. It means that it's a place that might create delays in your execution and that you potentially might be able to optimize. So it's where you should look if you want to know that you might have something you'd like to optimize. I would say when you have an application that has a lot of lines of code, and whenever you execute something, a lot of things execute, it might even work the way you expect it to work. Like the duration of the execution might not be what you consider to be long. But do you really know if that's the best execution you can get? If you, of course, you might not care that much, but if you care and you really want to get into the best execution, then what you want to do is to profile the CPU and memory and make sure that you identify all the hotspots. And when you identify the hotspot, you can first of all you find them, and then after finding them, you go there and you investigate deeper to understand if there's something you can optimize or not. It might be that nothing you can optimize, so it doesn't mean that you have a hotspot is necessarily something bad, but you might be able to optimize it, or at least you understand where the latency comes from. There are different places where latency can come from. So this is how you see, for example, in JProfiler the hotspots. The JProfiler is it's an excellent profiling tool. A little bit expensive, but it's a quite good tool. It helps you visualize easier the things than you were doing with Visual VM, which is my first screenshot here. But both of the tools, they help you somehow identify the hotspots. So there are different ways First of all, you can simply take a look at the timings, as I will show you, which is similar in both applications. Or if you have the money and you invest and you have a JProfiler, then you will have a chance to even get more advanced visualization tools, such as, for example, what you see here is called a flame graph. A flame graph is an excellent way to visualize the execution, because what you visualize on the horizontal is the execution of the methods relative to one another. So the layers in a flame are the methods executing, and what you see above, for example, is every method's execution, how much it took relative to the one below. So for example, here I can see I have a find purchase by product names, which called get product names for purchases, another method from another object. They both take the same time, which tells me, without even looking into the code, that this is the only method called by this one. So this method calls one other, which further calls two of them. So you see, then the next layer splits into two. And what you see important here is not only that split it into two, but also that this one took a less longer time to execute than the right one, which is the find all of a repository, which basically further goes into probably the database and gets some data from there. So it's a way in which you can instantly, by the horizontal and vertical view, understand what's being called and what relative to one another in terms of calls, method calls, might cause the delay. So you want to go further always on the path that represents the biggest delay. Find out if something creates a large delay. Of course, this kind of a visualization tool, unfortunately, you will only have with a tool that is licensed. We can try it if you want. So let's try it. Why not? So I prepared for you here a second project. Let's take this one. It's a very simple project where the delay is caused by a proxy. Now I would like to, instead of showing you the code, run the application, use some profiling and try to understand together with you, without looking into the code, try to understand what actually causes the delay. Is our application causing a delay, or is something else? Let's see how can we figure out something like this. So theoretically, I should be able to see again the execution, and I'm going to use a sampler. One advice from my side, always sample an execution before profiling it. There is only one exception for that, reactive applications. But whenever you start an investigation, sampling is the top of the mountain view of what happens with the CPU and memory in your application. Why is it important to sample always first before profiling? Because sampling is less intensive in resources the profiling tool needs. So whenever you use the profiler, you will always have to restrict the classes in a real-world application as much as possible to only those that you suspect they create a problem. That's why this is something which means intercepting all the classes from my code base. This is something that only works, for example, in a demo application. In a real-world application, I would have to specifically put here exactly the package or the packages or even the classes that I'm suspecting. But to find out what I'm suspecting, I'm using sampling first to have a top of the mountain view. So if I'm sampling now my application, I press the CPU sampler, which will sample the execution time, and I'm calling that method, which I think it's called demo. Let me just make sure. Okay, this is the endpoint. So I'm just going here and say demo. I'm waiting a bit. You see, it takes some time. I want to find out what's taking this long. So it took a little bit over 5 seconds to execute and get me the answer back. And I'm going here, and I see that something has been sampled. And I try to find out what exactly took a long time to execute. So to find that out, I'm going to find first which is the task that has been created in my executor, and I found it pretty easy because in this case is the only one. And then I can go up to the point where I see something happens with the time here. But it's something curious. At the very end, I see a get response code, and what I see, it's on the right column here called total time CPU is 0 milliseconds, while the total time is 5 seconds. It's very important to understand the difference between the two timings here. The total time CPU means how much the application really worked, while the total time, it means how much the execution really happened. So what does this read here is actually the execution took 5 seconds, but the application didn't work at all. What could that mean? How is it possible an execution to take 5 seconds, but the application not to work at all? Well, it's simple. It means that the application waited for something. So we can only figure out here, of course, very easily looking at the code and the execution stack, that, of course, probably because it got out into an HTTP URL connection get response code, it simply means in this case that the application waited at the socket to get data from the endpoint. So it's not our application having the fault, it should be the other service we are calling having the fault. So then in that case, we have to figure out why that service took a long time to execute. There are situations where the total time can be small and the total time CPU can be small and the total time can be large, and in which our application has a problem. And that's when we have a multi-thread architecture and we, by the use of badly implemented locks, we might spend a lot of time making threads waiting. But that's a more complex stuff, which is not necessarily very much related to modern Java applications. So I'm going to skip the subject from this presentation. But if you are interested, you can find an excellent discussion about it in How to Read Java, the third book I'm writing. So now, if you want to prove that what I say is right, of course, you can go to the code and you will find out that what I'm doing here is actually I'm calling HTTP bin org, which is a nice tool implemented that allows us to call us plenty of demonstration endpoints. This one is an endpoint where you give a number of seconds and it creates a delay for you. So the reason why you see the delay is basically because I implemented the example on purpose to give you the 5 seconds delay. So indeed, we understood, we investigated the situation and we understood the code right. It is indeed the other application creating the problem and not ours. Going back to my presentation, using call graphs. This is a third tip that I'm gonna share with you, and a very useful one when you are learning. So learning, when you investigate code, there are different reasons why you investigate the code. You might have an issue, a bug, and you want to find out the root cause so that you can solve it. But at some, you might do that for fun, for example. Some people try to simply investigate how something they don't know works. And I've even seen a presentation earlier about open source where the speaker told us they do recommend us do that on open source. I actually shared that opinion, so I do recommend you as well using open source software. That's the way I've learned very well Spring Security. That's the way I've learned Hibernate. That's the way I've learned Reactor Core. Every framework I'm learning, one of the things I'm doing, aside from learning documentation, reading books, watching tutorials, is going myself and profiling and debugging on that problem. Using call graphs is an excellent profiling technique you can use to better understand the application you are watching, or what's behind the scenes for that application, which means what specific framework you are using. Unfortunately, to have access to a call graph, you need more than Visual VM. You need JProfiler or a similar tool which is licensed. I have an academic license that I use, but of course, if you don't afford that, you will have to rely on the stack trace. However, if you do afford that, or maybe your company gives you the privilege of using that, call graphs are an excellent tool to learn. So you can even execute a call graph. So let me actually start my JProfiler here. And if you want to connect to the same application and make a call graph, you will see how easy that is. And what you will see, again, why I find it useful is because you won't only see the classes of your application, but you will see all the classes from the frameworks. So let me try to do that very fast, very quickly, just to prove you. So CPU call tree, and then you simply, let's call again the demo endpoint. And at the very end, well, you can change this into a call graph. So maybe I should have actually enabled the call graph before. Well, you should have. I should have seen the call graph. I'm a bit surprised I don't see it. Oh, show call graphs. Okay, this is the way I should have seen it here as well. Anyway, might be a bug or something, but this is how a call graph looks like. So you see, you can go. It's the same application with the delay. With the delay, you can see exactly here fame. So I identify here immediately that my controller class directly calls something called fame. If I don't know that is basically open fame, I can research that, and that's what I'm doing usually when I don't figure out. Then I go further, and I can see exactly the architecture behind open fame, which maybe in case of open fame it might not be that interesting, but in case of spin security or something that is more complex, it can be an excellent way to visualize what exactly is called. And that's how I found out, that's how I understood very well how for example, the authentication manager, the authentication providers work, user detail service, password encoders, and so on and so forth, how the entire filter chain, what kind of filters do I have active on the application. So it's pretty simple to visualize them on a call graph. A very easy way to see everything like this. So I do basically recommend you use the call graph. Then, of course, an app's memory usage. I thought about introducing this point or not in my presentation, but then I actually got, in the past couple of months, a couple of issues that were pretty much impossible to solve without investigating how memory is used by my application. So, of course, profiling apps memory usage might look like an easier, a more low-level way to understand your app, which might be less encountered in real-world today's applications, since we are pretty much using a lot of frameworks which are pretty much used by everyone and tested pretty roughly. But sometimes memory problems are not necessarily related to your code. And I will give you an example of the last issue I've investigated in these regards, which happened actually yesterday. So yesterday we, with my team, we investigated a problem where only on a specific virtual machine for a specific operating system with a specific flag added, the garbage collector didn't work properly, causing something that looked like a memory issue. The problem, the real cause of the application, I didn't find it simply just using the profiler, but I started the investigation by using the profiler. And that's something pretty easy because, for example, even the simplest tool, Visual VM, which again is my favorite, its simplicity is basically one of the things I like the most, helps you identify how the memory is used, helps you identify which objects are occupying the most of your memory. For example, this is a case where in my example, an object called product has been created multiple times, spending a large part of the memory. You should always look for direct objects your app uses instead of JDK objects. And when you find out something like this happens, where there are two cases usually, it's either your application has a memory leak, which means it at some point doesn't deallocate the references of some objects, and it continuously keep them, so the garbage collector cannot deallocate the instances from the memory, or it can be that the garbage collector doesn't work right. So in my case, it was the second option. So yeah, the investigating is pretty simple. The way you saw me earlier using the CPU button, you have the memory button, and then you can find exactly what kind of objects might cause problems in your applications, and that's where you at least start the investigation from. Okay, the fifth point that I wanted to show you, because it's almost the end of the presentation and I don't want to be kicked out, I would like to finish in the next 3 or 4 minutes, is profiling reactive applications. It seems that reactive applications, and especially reactive core, is more and more used nowadays. There are use cases where having an event-driven approach is much better. And the only thing I want to share with you, the most relevant and different thing from other applications I want to share with you about profiling reactive apps, is that when you try profiling reactive apps, start directly with profiling, not with sampling. So this is the key point I want to share with you. Usually, whatever application you are working with, you start with sampling for the top of the mountain view, and then you continue with profiling. For reactive, for the purpose of the way the reactive app is built behind the scenes, that netty server, the way it uses, it exchanges the thread per request philosophy to a task, say, per request philosophy, it makes things more difficult for only sampling. So you really need to go profiling to see something. I will leave this for another presentation because I kept it very long on the first examples. And I do invite you as well, read my third book where I explain this as well. I promised you a couple of codes. One of them is a 35% discount code for any Manning product. And the second thing I'd like to share with you before ending my presentation is actually a couple of codes for you to get a free ebook. So you get ready, guys. In the chat here, I'm going to post it. So you just on manning.com, you go to How to Read Java, which is my latest book. And then you can use one of these codes. The codes are only usable one time, which means that the first of you who will be lucky to be able to use the code, we will get the ebook for free. It's only for the ebook. I don't see other questions. Maybe if you still have questions, don't forget that you can just find me on YouTube, Twitter, LinkedIn, and I will be very glad to share my knowledge with you. And I will end this presentation by saying again, thank you very much for your attention. Thank you very much for being so many here with me. Thank you very much for the organizers for inviting me, and hope to see you soon, preferably in person next time. Cheers.